Hello and welcome to Build Society. I'd like to introduce the Bella Lake Resort project by RP-Karmi. This video will explain the prefabrication of components in the shop. In this episode, we are building with CLTs. CLT stands for cross-laminated timbers, and these are being used for the Bella project here in Kuopio, which consists of 10 cottages, and we're using this stuff for the walls and the roofs. I have this set up here just to give you a quick demonstration as to how these are put together. You can have multiple layers, but these walls have 3, and each layer runs perpendicular to the one before it. So the first layer is vertical, and then we have horizontal layer in the middle, and finally a vertical layer. So that's how you get that cross. Each layer is 26 millimeters thick of fir wood, and they are machined and pressed together using structural adhesive. This product comes from a company called CLT Plant in Kauhajoki, Finland, and they're going to get a wax finish put on the exposed surfaces. I really like working with this stuff, and I'm excited to show you what we're doing in the shop here with them. So let's get into it. Before we get onto the walls, I'll tell you about these floor components. They are framed with laminated veneered lumber and sit on top of the foundation walls. Low-density fiberboard and rock wool insulation are put between the joists, and then the floors are sheeted with oriented strand board. Now onto the walls. Each building has 7. The guys are rolling in a pack of CLT panels here. Starting with the right side wall, the panel gets lifted onto the work table, with the interior side facing up. All the interior surfaces get sanded, just to get rid of scratches, divots, and discoloration. We can now move to the exterior side. This is Ari, and he's nailing on LVLs to add strength to this end, which overhangs the foundation and holds a terrace. Rows of 6 100mm nails are shot every 300mm. Here, our team lead is working on the framing for this part of the wall, and I'm just over to the left building out the door. These framing members will accommodate the rock wool and strapping. There's nothing bearing on them, as the CLT panels will carry the load of the roofs. These are fastened with screws and angle brackets using ring shank nails. This is conduit for routing electrical wire, which will be installed on site. Let's carry on with the left side wall. It's the exact opposite of what you just saw.
So now we can get into the insulation. This is Rockwool's WPI Plus 33, meant for exterior applications, as it has a wind protective layer and is denser than interior insulation. If this is new to you, Rockwool is indeed made from rocks that are melted. The molten rock is spun kind of like how cotton candy is made. Glass insulation has a similar process. This creates a fiber that can be pressed into these bats. Rockwool is fire and moisture resistant, is durable, great for noise reduction, and has high thermal efficiency. It can make the skin itchy, but is otherwise fine to work with. Once installed, we cover all the seams with Rockwool's RockTech twin line tape. This is vertical strapping, which is fastened with 260 and 280 millimeter structural timber screws placed every 600 millimeters. They go through the Rockwool and bite into the CLT panel. The 260s go straight down, while the 280s at the top and bottom of the wall are put on an upward angle to carry the load of the strapping and siding. We use squares to measure the top and bottom of the wall to make sure it has a uniform thickness. The measurement is taken at the framing components. This is the horizontal strapping that the siding will be nailed to. You can see that I'm checking the board for straightness. I check for straightness along the length and width of the board. Cupping is the term used when the width of a board has a curve. Since these boards are flat sawn, they almost always have a curve in the opposite direction of the annular rings. As the board dries, the wood closest to the bark shrinks more than the wood closest to the center, as the center is denser and stronger. I like to fasten each board with the concave side facing down, which makes it easier to keep everything straight and level. I like to keep this in mind when working with all kinds of lumber. In the end, it should look something like this. I also like to stagger the board joints or place them in a zigzag pattern. Setting the joints in a line could create a weak spot or a slight deviation in the wall, which could transfer to the siding. This technique applies to most areas of construction, with the idea that load and stress points should always be spread out. Since the top and bottom of the wall have been set to the correct thickness, a straight edge is used to level out the rest of the wall. To lift the walls, we're using Rothoblast Wasp hooks. They're quick to install and provide a secure connection for lifting these walls which weigh up to 2,000 kilograms or 2 tons. The same thing goes for these end walls. The opposing side of the buildings have large glass windows and sliding glass doors.
Yeah.
These little walls are more for aesthetics. The midsections are fully cut out on site. The walls are kept intact for ease of installation, so guide cuts are done in the shop. The last two walls are the interior load-bearing partitions. Like the long exterior walls, they overhang the foundation, so LVLs are added for reinforcement. These walls divide the buildings into two sections, therefore by code, they must be noise and fire resistant. Both are layered with fire-rated drywall, and one side gets a layer of 50mm thick rock wool. The drywall is cut to size by scoring and snapping off the unwanted piece. A trick I use for cutting holes in drywall is reversing the direction of the hole saw. If you go in the normal direction, the teeth will likely bite and jam into the paper, which shreds the drywall and it's hard on the wrists. The insulation is covered with plastic for protection until the wall is installed. Now these are the top parts of the roofs. These rafter-like pieces are the only components that are built in the shop, as the roofs are done on site. We'll get into the roofs more in another video, but just to give you an idea, these sit on top of trusses which sit on top of a CLT ceiling panel. All 7 walls for one building are now complete. They're covered with shrink wrap and sent off to be assembled on site. And we'll repeat this process 9 more times. We'll be on site for the next episode where I'll walk you through the assembly process. If you enjoyed this video, please like, share, and subscribe. And if you really want to encourage Build Society, you can support the channel at patreon.com/buildsociety. Thank you so much for following along. Until next time.